In this series of videos, I'm actually going to talk about integration techniques, and this is generally taught in Calculus 2, where you learn all of these integration techniques. In Cal 1 you learned how to integrate specific functions, but here we're going to learn techniques. So the first technique I'm going to show you is how to integrate by parts. And it turns out that if u is a function of x and du is the derivative of that times dx, and v is a function of x and dv is actually the derivative of that dx, then integration by parts states the following. Anytime you want to integrate u times dv, that integral is equal to uv minus the integral v du. Now, after you do this, set it up like this formula, then you're going to have to integrate the integral v du. So in evaluating these integrals, you're going to have to actually evaluate another integral at the end. So let me show you how this works on a couple simple examples. So for instance here, I have this integral of the function x e to the x dx. So what I could do here is I could let u equal x, then du would be dx. So if I let u equal x, then for the rest of the formula, since that just covers u, everything else in that integral must be dv. So the e to the x dx, that must be the dv. So dv equals e to the x dx, and then to get v you just integrate this, and so v would be the integral of e to the x dx, which is just e to the x. And we don't need to add the constant here because we'll add the constant at the very end. Okay, so now that I have u and du and dv and v, now I can rewrite this integral as uv minus the integral of v du. So I rewrite the integral as u, which is x, times v, which is e to the x, then minus the integral of v du. Now v was e to the x and du is dx. Now I have to integrate this integral, and that's easy to do because if you integrate e to the x, you just get e to the x. So my final answer would just be x e to the x minus e to the x plus c. Alright, let's look at another one. Here I have x times natural log of x dx. Now here I always have to pick one of these functions to be u, and then everything else is going to be dv. Okay, well I'm going to let u be natural log of x because I can take the derivative of natural log of x to get du, and du would be 1 over x dx. See, if I'd let v dv be natural log of x, then I wouldn't know how to integrate it, or even if I looked up a formula, it's probably going to be complicated. So it's better to let u equal natural log of x and then let dv be the other factors, the x dx. Now if dv is x dx, I know how to integrate x dx. That's just x squared over 2. Okay, so now apply the formula, and so this now would equal u, which is natural log of x, times v, which is x squared over 2, minus the integral of v, which is x squared over 2, times du, which is 1 over x dx. Well, this is just x over 2 when you simplify it, so you're really just taking the natural log of x times x squared over 2, and then you're integrating x squared over 2. So I'm just going to factor the 1/2 out of that. And did I say x squared? This is actually x over 2, and then if you pull the 1/2 out, you're integrating x. And so to integrate x, that's easy. If we integrate x, we get x squared over 2, and then you can multiply it by the 1/2, and then that term becomes x squared over 4. Now don't forget this other term that we had carried along with us. So your final answer is x squared times natural log of x over 2 minus x squared over 4, and then you add the constant at the end. Okay, here's a couple more. On this one, I'm going to let 6x be u, and that means e to the minus 3x dx. That has to be dv. So now the derivative of 6x is just 6dx. And if you integrate dv to get v, if you integrate e to the minus 3x, you just get e to the minus 3x divided by minus 3. So now if we apply the formula, we take u, which is 6x, times v, which is e to the minus 3x over minus 3, and then subtract the integral v du. Well, here's the v, this fraction is the v, and the 6dx is the u. And then if we clean this up a little bit, this would actually be minus 2 times this exponential function. So we'd have minus 2 times this exponential function. But remember, we're subtracting this, so if you do minus a minus, that's going to give you plus. And I went ahead and factored the 2 out. Now, this other term, it's simplified because minus 3 went into 6x and gave me minus 2x. So I have minus 2x e to the minus 3x. So bring that over here and then put it with the integral. And now I just have to evaluate this integral, which we know this integral integrates to e to the minus 3x over minus 3, and then we multiply it by 2, and so we get minus 2/3 e to the minus 3x for that integral. And then go ahead and bring the first term down and put those two together, and you get your final answer. Minus 2x e to the minus 3x minus 2/3 e to the minus 3x plus a constant. Now the other thing you might do is you might need to write these in the denominator and change them to positive exponents if your instructor prefers it that way. The next one, it's x squared times the natural log of 5x. So on that one, I'm going to let u be the natural log of 5x, and then du would actually be just 1 over x. And then if u is natural log of 5x, then dv would have to be the rest of it, which is x squared dx. And then when you integrate both sides of this, you get v equals x cubed over 3. So now apply the formula. uv would be natural log of 5x times x cubed over 3. Then minus the integral of v du would be minus the integral x cubed over 3 times 1 over x dx. Now I'm going to factor the 1/3 out of this integral, but x cubed over x is just x squared. So now bring this term down right here, and then bring your integral down. So I have minus 1/3 times the integral. And then the next step, I'm going to evaluate the integral. So just carry this term along, so carry it over here, and then evaluate this integral here, and it integrates to x cubed over 3, and then you multiply it by 1/3, and so you get this term, x cubed times natural log of 5x over 3, and then minus x cubed over 9 plus a constant. Now I listed a couple of practice problems here if you want to freeze the video and give those a shot and try to work them. The answers are listed as well. Okay, here's a definite integral integrated using parts. So on this one, I'm going to let u be natural log of x, then du is going to be 1 over x dx, and then dv would have to be the x cubed dx, and then v would be x to the 4th over 4. So do your uv, you get natural log of x times x to the 4th over 4 minus the integral of v du, which would be x to the 4th over 4 times 1 over x dx. And then just bring this term down, and then I can factor the 1/4 out of the integral, and I'm left with x cubed, because x to the 4th over x is x cubed. Then if you integrate this, you're going to get x to the 4th over 4 times a 4th. So that, and actually it's times a minus a 4th. So this is just going to be minus x to the 4th over 16. And then here's my first term. So I have my first term minus x to the 4th over 16. And if you integrate that from 1 to 4, you just plug 4 in first. So if I plug 4 in, I get 4 to the 4th times natural log of 4 over 4 minus 4 to the 4th over 16, and then subtract, evaluating this at 1, and I get 1 to the 4th times natural log of 1 over 4 minus 1 to the 4th over 16. And then you can do the rest of the arithmetic here. I ended up with 64 natural log of 4 minus 16 minus a negative 1/16. And so that's actually 64 natural log of 4 minus 16 plus 1/16, or approximately 72.79. And there's some practice problems if you want to give those a crack there. Okay, now we can also, these also come in handy sometimes when we have x or powers of x in trig functions. So here I have x cosine x dx. So I'm going to let u equal x, then du would be dx, and then if u is x, dv would have to be the rest of it, cosine x dx. And if you integrate cosine x, you just get sine x, so v would be sine x. So then you just say, okay, uv, x times sine x, that's uv, and then minus the integral of v du. Well, that would be integral of sine x times dx. And now that's just a simple sine integral, so if you integrate that, if you integrate sine x, it integrates to minus cosine x, but since you already have a minus here, you'll get minus a minus, which gives you a plus cosine x. So your final answer is just x sine x plus cosine x. Okay, here's one more. Here I'm going to let, just to integrate natural log of x, you let u equal natural log of x, and du is 1 over x dx. And then, so now this case, dv is just going to be the dx. So when you integrate that, v is just x. So then you do the uv, so we get natural log of x times x, which I'll write like this, and then minus the integral of v du, so x times 1 over x dx. Well, that's just going to be dx. So you get the integral dx. And then, so bring down your x natural log of x, bring down the integral dx, and then integrate dx, you just get x. So you get x natural log of x minus x plus a constant. So now you have a formula for integrating the natural log of x. Sometimes you have to integrate repeatedly by parts to make it work. Like for instance, watch what happens here. On this problem, I can let u be x squared, then du is 2x dx, then dv would be e to the x dx, and v would be e to the x. So then if I write that as uv minus the integral v du, I actually get 2x e to the x here. So now let's evaluate this integral using parts again. Let's do a second integral. So here I'm going to let u equal 2x, and then dv would be e to the x dx. So the derivative of u would make du be 2dx, and then integrating over here, v would be e to the x. So this integral becomes 2x e to the x minus the integral of 2e to the x dx. And then you would have 2x e to the x, and then when you integrate this, you just get minus 2e to the x plus c. And then finally, you're going to take this part right here. You have to take this part right here. We don't really need the c yet, and put it in here. And since you're subtracting it, all the signs will change. So that'll become, you bring down the x squared e to the x, and then you have minus 2 x e to the x, and then plus 2e to the x, then plus a constant. And remember, the signs change because you're subtracting that term. So there's your final answer. On the next video, I'll go ahead and continue this. I'll show you some more integration by parts, and I'm going to show you an example of what I call the foldback rule using parts integration, and I'll also show you what tabular integration is on the next video.